NASA's Voyager 1 spacecraft, the farthest human-made object from Earth, has become more than just a scientific probe. It has turned into a symbol of humanity's relentless curiosity and determination to reach beyond our boundaries. For nearly 5 decades, it has carried our questions, our hopes, and even our message to the stars. Since its historic launch, Voyager 1 has transmitted streams of data from the remotest corners of our solar system and now beyond, reshaping our view of the cosmos. Yet, its latest transmissions carry something unusual, signals that don't quite add up, puzzling scientists and sparking debates worldwide. Are these irregularities merely technical glitches born of an aging spacecraft? Or could they represent something far more profound, perhaps even evidence of a presence we have long wondered about? Voyager's story begins not with itself, but with the legacy of daring missions that preceded it. Humanity's urge to explore has always been driven by an insatiable hunger to solve mysteries. The Pioneer 10 and Pioneer 11 spacecraft, launched earlier in the 1970s, were the first emissaries to venture into the outer solar system. They laid the groundwork and gave NASA the confidence to attempt something even more ambitious. And so, in the late summer of 1977, 2 twin spacecraft, Voyager 1 and Voyager 2, were launched on trajectories that would forever alter our understanding of the planets and the vast expanse beyond. Voyager 2 left first on August 20, followed closely by Voyager 1 on September 5. Despite its later launch, Voyager 1 soon overtook its sibling, setting itself on a faster course thanks to a carefully planned trajectory. Each spacecraft was surprisingly modest in size, weighing just 721 kilograms, lighter than a small family car. Yet inside, they carried some of the most advanced technology of their time, from cameras capable of photographing worlds billions of kilometers away to instruments designed to measure magnetic fields and plasma waves. By December of 1977, Voyager 1 had already outpaced Voyager 2, and it began a journey that would redefine planetary science. In 1979, the spacecraft arrived at Jupiter, humanity's first close encounter with the gas giant on such a scale. It conducted a 100-hour observation of the planet, producing thousands of images that stitched together into mesmerizing time-lapse sequences. For the first time, we could witness Jupiter's massive storms in motion, including the Great Red Spot, a storm larger than Earth itself. Even more astonishing, Voyager 1 discovered that Jupiter had a thin, previously unknown ring system, and it identified 2 new moons orbiting the giant. Suddenly, the Jovian system was revealed as far more complex and dynamic than scientists had imagined. Voyager 1's next great encounter was with Saturn in 1980. To ensure it passed safely while still conducting science, NASA executed careful course adjustments, particularly to avoid a hazardous collision with Titan, Saturn's largest moon. The flyby revealed Saturn's rings in unprecedented detail, showing intricate structures and divisions that no telescope from Earth had ever hinted at. Voyager 1 also discovered several new moons, including Mimas and Enceladus, bodies that would later prove to be of profound scientific interest. With its Saturn mission complete, Voyager 1 was flung on a trajectory that carried it away from the solar system's planetary plane. Unlike its sibling, Voyager 2, which continued on to Uranus and Neptune, Voyager 1's destiny was to head directly toward interstellar space. By the early 1990s, it was already far beyond Pluto's orbit. On Valentine's Day in 1990, from a distance of nearly 6 billion kilometers, Voyager 1 turned its camera back toward Earth and captured what became one of the most iconic images in history, the pale blue dot. In this photograph, Earth appears as a faint speck suspended in a sunbeam, a fragile mote in the immensity of the cosmos. This single image transformed how humanity viewed itself, not as rulers of the universe, but as humble inhabitants of a tiny world in a vast, unfeeling void. The 1990s marked the beginning of Voyager's transition into interstellar exploration. Though no longer able to photograph planets, its instruments continued to collect priceless data. In 2012, Voyager 1 achieved a milestone once thought impossible. It crossed into interstellar space. For the first time, a human creation had left the protective bubble of the heliosphere, entering a realm dominated by material and radiation from the galaxy itself. Instruments on board detected a sudden change in particle density, confirming that it had left the solar wind behind and was now sampling the true interstellar medium. These measurements have been invaluable. Voyager detected cosmic rays streaming in from distant supernovae and star-forming regions, providing clues about galactic processes far beyond our reach. Its plasma wave detectors map the boundary layers of the heliosphere, including the termination shock, the Helios heath, and the point of interstellar transition. Such data revealed that what scientists once thought of as empty space is, in fact, filled with complex structures and turbulent interactions. Voyager 2, meanwhile, carved its own legacy, making humanity's only flybys of Uranus in 1986 and Neptune in 1989. It recorded Neptune's astonishingly fast winds, blowing at over 2,000 km per hour, and observed geysers erupting from Triton, Neptune's icy moon. These findings shattered the idea that distant worlds were frozen and inactive. They were alive with weather, geology, and strange processes we are only beginning to understand. What made both missions possible were gravity assists, ingenious maneuvers that used the gravity of planets to sling the spacecraft onward at higher speeds. Jupiter's immense gravity catapulted Voyager 1 toward Saturn, while Voyager 2 used both Jupiter and Saturn to continue on to Uranus and Neptune. Without these gravitational slingshots, such a grand tour of the solar system would have been impossible. But Voyager's story is not just about science, it is about humanity itself. Both spacecraft carry the golden record, a time capsule of Earth encoded on a phonograph disc. It contains 55 spoken greetings in different languages, music from across cultures, and natural sounds from Earth, waves, wind, thunder, and even whale songs. It is humanity's first deliberate attempt to communicate with any intelligent life that might one day encounter our probes drifting in the stars. Whether or not anyone ever finds them, the golden record symbolizes a message of hope, peace, and curiosity. Today, more than 20 billion kilometers away, Voyager 1 still whispers back to Earth. Yet in recent years, its transmissions have begun to show strange irregularities. At times, data arrives garbled or inconsistent, with signals suggesting orientations or conditions that don't make sense. NASA engineers suspect aging hardware and software faults. After all, the spacecraft was built with 1970s technology and has been exposed to the harshest environments in existence for decades. Still, some wonder, what if these anomalies aren't just technical errors? Could they be the result of interactions with phenomena we don't yet understand? Could something, or someone, be out there? Though the alien hypothesis remains speculative, it has fueled imagination across the world. The truth is likely less sensational but no less important. Even technical malfunctions teach us about how long-term space exploration can be sustained. The fact that Voyager 1 continues to function at all after nearly half a century is a triumph of engineering. NASA has been carefully rationing its power, shutting down non-essential instruments to keep its most vital systems alive. This delicate balancing act may keep the spacecraft running until around 2030, when its power source will finally be exhausted. Yet long after its instruments fall silent, Voyager will continue to sail on, a tiny ambassador from Earth wandering the galaxy. In perhaps 40,000 years, it will pass relatively close to another star. By then, humanity may have colonized other planets or ventured into interstellar space itself. Or perhaps we will be gone, leaving only this silent traveler as proof that once, long ago, a species on a small blue planet dared to dream of the stars. The legacy of Voyager is unmatched. It has revealed new moons, discovered volcanic activity beyond Earth, mapped the boundaries of our solar system, and given us some of the most iconic images ever taken. But beyond the science, it has given us perspective. The pale blue dot reminds us of our shared fragility. The golden record reminds us of our shared humanity. And Voyager's continued journey reminds us that exploration is never truly finished. As we await new signals from this aging spacecraft, we are reminded of the boundless curiosity that drives us, and of the vastness of the universe still waiting to be discovered.